Hello guys, and welcome to electronic tutorials. Today's lesson is about finding the current flow in each resistor and the voltage across in each resistor using Kichhoff law. So we're gonna label the polarity and also the direction of the current. So as you can see that in our circuit we have R1, which is 4 ohms, and R2, which is 2 ohms, and R3, which is 8 ohms. And you can see there, since if we take this direction and this direction, this is going to be our loop 1, this is going to be our loop 2. So the polarities goes like this, okay? And then our I1 is gonna goes like this, I1 there, and then this is our I2 go in this direction, and our I3 go in this direction. Okay, so now applying KVL on loop 1. So you're just gonna have to imagine that loop 2 is not there for now. So then we can see that our power source goes from 4 volt positive, from negative to positive, and then when you go to R1 you can see that its voltage goes from positive to negative, so therefore it's going to be negative for I1, and our I3 is our R3, sorry about that, our R3 goes from its voltage goes from positive to negative, therefore this is I3 equals to 0, and therefore if you take this to the right side you're gonna have 4 I1 plus 8 equals to 4. This is our equation 1. Okay, this is our equation 1. And now on loop 2, when we apply KVL on loop 2, we start from the power source. You can see that our power source goes from positive to negative, so therefore it's going to be negative 6. And then we go to R3. You can see that its voltage goes from negative to positive, so therefore it takes positive. And then we go to R2. You can see its voltage goes from positive to negative, so therefore this is plus 2I2 equals to 0. And if we take this is negative, because our voltage here goes from positive to negative. This is negative, so what that? So therefore our equation is going to be like this: 8I3 minus 2I2 equals to 6. This is our equation 2. So this is our equation 2. Now by applying KCL, you can see that our I1, since we're applying KCL in this point, you can see that our I1 is the one that is entering, and I2 and I3 are leaving the point, so therefore I2 plus I3, that's our equation. So therefore this, we're gonna equate this as equation 3, and then by substituting equation 3 into 1, since we have I1 here, into equation 1, so you're gonna have 4 I2 plus I3 plus 8 I3 equals to 4. It's going to be So our new equations is this one. So we're going to equate this one as our equation 4. Okay, so we're going to equate this as our equation 4, and then we're going to compare our two equations now. Equation 2 and 4. Now let's compare equation 2 and 4. Our equation 2 is this one, plus 8i3 equals to 6. This is our equation 2, and our equation 4 is So when we look at these two equations, you can see that you can eliminate I2, but then it's going to cost us to multiply this equation by 2. Okay, so if we multiply this equation by 2, we're going to have, this is going to be minus 4, and then it's going to be 16. So therefore this is going to be like this, minus 4 I2 plus 16 I3 equals 2, and therefore this is going to be 8. Well, since there is, this is going to be 12, since it's 6. 2 multiplied by 12, 2 multiplied by 6 is 12, and then our equation, this one is still the same one, which is I2 plus 12 I3, and therefore this is 4. There is 4. It's 4. So therefore, when you add these two equations, you can see this is going to be 0, and this is going to give us 16 plus 12 is 24. It's 28. Yes, it's 28. It's going to give us 28. I3 equals 2, and therefore this is going to give us 16. Yes, this is going to give us 16. 12 plus 4 is 16. And therefore we're going to divide 28. Going to divide 16 by 28, and our I3 is 0,571 ampere. Okay, and now since we have found this, we're going to substitute I3 into equation 2 and see. Yes, we're going to substitute this into equation 2, and we have our equation 2. Where is it? This is our equation 2, so therefore it's going to be 8, which is 0,512. Let's multiply this. It's going to give us 4,568 minus 2i2 equals to 6. When we take this side, 2 equals to 6 divided by 2, and then our I2 here is minus 0,716 ampere. Punch that in the calculator, you get this value. And then since now we have I3 and I2, we can find I1 using our equation 3. So I1 equals to I2 plus I3. So I1 equals to, as you can see, our I2 is minus 0,716 plus our I3 83, which is this one, 0,571. And this gives us minus 0,145 here. And then, since now you have all the current, I1, I2, now you can just find the voltage in each resistor. So you know that V1 using the resistor V1 which is going to be here obviously, and then our current here is minus 0,145 multiplied by our resistor, which is 4, and then punching that in a calculator. 145 and 4, you get this minus 0,58 volt. And then V2, our V2 is going to be using our I2. Our I2 is negative 0,716, and our resistor is 2 ohms here. I'm going to find the answer. I'm going to leave that to you. And V3 using the same thing. Our voltage, our current here is 0,571, and the resistor is 8 ohms. And then you are done. Thank you guys for watching the video, and also don't forget to subscribe to find more videos on electronics tutorials. Thank you guys.